Welcome to the Roundtable Perspective. I'm your host, Tom Roach, and I'm joined today by my guest, Dr. Stephen Cousins. Dr. Cousins is Executive Director of the Stanford University Robotics Center. Thank you for joining me.
Yeah, thank you for having me.
I know Stanford's been a pioneer in robotics starting in the 1960s, and your career in robotics started around 2007. So in terms of your career, what's happened in the last 20 years here that's important for us?
I think what changed in the last 20 years is that robots are suddenly next to people. In the early part of robotics history, robots were all behind safety cages in factories, and we didn't know how to make them safe enough to come out. Now we have things like self-driving cars, we've got delivery robots that are operating around people, even called cobots, robot arms that can be safely in the same workspace with another person. So we've gotten closer, but we're not touching people yet. So I think over the last 20 years, we've gotten to where we can perceive the world and operate around people. And the next phase is going to be, how can we actually help people?
And I know one of the big developments was the boom in the development of AI.
Yeah, AI has, especially over the last 12 years or so, had huge breakthroughs in language and image processing. And robots can benefit from those, right? You can have a robot that could take spoken commands and, figure out what to do and
Sure.
try to respond to them. And also the robot can look at the world. We have a robot at Stanford that's called a tidy bot. It will pick up anything that's on the floor, figure out what it is, and if it's laundry, it puts it in the laundry basket. If it's toys, it puts it in the toy basket.
I couldn't even get my kids to do that.
I know, that's why we have robots.
That's great. So you were at a company called the Willow Garage, I think, right?
Yes.
Tell us about, this is before you were at Stanford, but you did
Yeah.
some really pioneering work there. Tell us a little bit about that.
Yeah, Willow Garage was a really interesting think tank kind of place that was focused on impact first and worry about return on capital later. And so the goal of the company was to spin out, create advances in autonomous technology. We started off looking at self-driving cars and quickly switched to a personal robot project. We created a robot called the Personal Robot 2. And that PR2 was really the first humanoid robot in the US. There was some in Japan before that, but this one was unique in that the arms were safe to be around, and it led to a lot of interesting results. And with that robot, we built a robot operating system that is still like the dominant software for programming robots in the world today.
Oh, that's interesting. So I think I also saw a picture of one of these robots playing pool. Is that right?
Yeah, after we got the robot built, we said, what can we do quickly with this robot? And we had two projects that we called hackathons. They were 1-week projects. One of them was make the robot play pool, and we were able to get it to make shots. And the other one was called Beer Me, which was you would tell it to bring me a beer, and it would open up the refrigerator, pull out the correct beer, and bring it to you.
And we think that all of these scientists and engineers are dull people, and you came up with the Beer Me robot.
I think Beer Me is I think bringing you a beer is like the application that everybody wants from the robots.
Well, that's great. So some other things that came out of the Willow period?
So there was a really interesting email that I got from a gentleman named Henry Evans, and the emails went like this. I saw your robot on CNN. So this humanoid robot was on CNN. He said, I saw your robot on CNN, and I'm mute and quadriplegic. Yeah. And I'd like to try that robot as my external body. And this was sort of a strange email to get.
Sure.
But we had him come over and assess that, sure enough, he could actually, although he couldn't move his arms or his legs, he had good control of his head. And they put a dot on his glasses, and the camera on his laptop would track that dot and basically make the mouse move. So he's able to use an on-screen keyboard, and that's how he sent me that email. Wow. So we said, okay, he's actually got pretty good control. And that was interesting. About 2 months later, I get another email from him that says, I really want to try your robot, and I've designed the user interface that I want. Would you build it for me?
No kidding.
And so,
what was his background?
He was a CFO of a Silicon Valley company.
Oh, no kidding.
Until he was age 40, and he had a brainstem stroke, and went into a coma, and he came out of the coma like blink once for yes, twice for no. So really terrible situation. So he when he finally, we hired a student to build him the interface, and we had him back. And so he's sitting like where I'm sitting, and he's got, we were in like a straight table, not a round table like here. We were on a straight table, and he's sitting facing his laptop, and next to him is the robot. And it's got all these toys in front. We're thinking he's going to use the arms to pick things up. Like he said he might want to play Connect 4 with his kids. It's not what he did. First thing he did, he turned the robot on himself, and he started bringing the arm toward his head. And like we were like a little bit worried. We have a big red button we can push to stop the robot. He brought the arm right in front of his head, and then he scratched his nose.
Oh,
and it was the
wow.
first time in 10 years he had scratched his own itch, and he was so happy about it. And like this was an aha moment for all of us.
Because you didn't think, you were afraid to let him get that close too.
Well, we were worried about that, and we
Yeah.
were thinking that, what's he actually, like, what's he going to do here? We thought he would be, doing work. Like robots are for doing work, and
Right,
here
right.
this robot is for him to extend himself, which is a really interesting direction.
Yeah.
He wanted to shave himself. That was the next thing, and so he.
Please tell me you didn't give the robot a razor.
We gave the robot an electric razor.
Oh, okay. All
And we built a little holder for it, and then he controlled the arm to bring it close, and then he would do this. And then it worked so well that he shaved Professor Charlie Kemp at Georgia Tech from California. So he was like doing this remote shaving thing.
That's pretty interesting. So this developed into something you called Robots for Humanities, I think?
Yeah, so Henry called it that. So Henry had this idea that, here's a guy who, finds himself in this horrible situation and decides that he's going to, take what life's given him and do something. So he's given a TED Talk. You could look it up. He's got a whole blog that he's written about his experience. But he's worked continuously, and more recently, Dr. Charlie Kemp actually has left Georgia Tech in order to create a company to make a robot that's a little bit lighter weight robot that Henry can use, or people like Henry. Henry used this robot to play with his granddaughter. Now, you have to understand, his granddaughter didn't recognize him as a person, right? He's in a wheelchair. He can't move. He just sits there. She thought he was furniture, like literally. She's, just how she perceives the world. After he got the robot set up where he could have the robot play with her on his behalf, she started not only recognizing him as a person, she started giving him a hug before she went home.
Oh, wow.
Like a huge deal.
That's great.
Yeah.
Good story. And one of the developments that's more recent is haptic control, is that right? And you've been looking into that?
Yeah, so this theme of, like, let's have a robot that a human is controlling remotely. In Henry's case, it's because he doesn't have the ability to operate on the world. But in other cases, we've got a robot that can go 1,000 meters, called Ocean One at Stanford, can go 1,000 meters below the surface of the ocean. No divers can go that deep. And the robot is controlled by a person who's holding onto these haptic devices. The haptic device is a robot, but it's a robot that's going to apply forces to your hand here.
Maybe we should define haptic here.
So haptic is basically touch, right?
Yeah.
And so you can see in video games sometimes there's like vibration, which is a simple kind of haptics. But this kind of haptics is, when if the robot arm touches this cup, as I'm the one controlling it, I'll feel that touch, and then I can grab it.
You're wearing a glove or?
I'm holding onto a controller that I can open and close the gripper, for example.
Okay.
But there's actually a lot of work on gloves and other ways. We're getting to a place where we can create avatars for ourselves. If we're, quote unquote, able-bodied, we're operating the avatar using all of our motion sensors. If we're not able-bodied, we're operating it using our head or whatever controls we have.
Yeah. Now, I know you're interested in some non-traditional uses of robotics, so where's that taking you?
Well, so one of the things that I discovered when I just came back to Stanford is in mechanical engineering, they're looking at these micro robots. So they're like literally it's 2 millimeters by 3 millimeters. So it would be tiny on my fingertip. I'd have to like pick it up like that.
Okay.
And
We'd see it.
You could see it, yeah.
Yeah.
But it's very small. And the robot is, in order to make it that small, they take out the battery, and they take out the motor, and they take out the sensors, and they take out the computer. And you're like, well, what's left,
Yeah.
right? Well, all that stuff is kind of in the system surrounding it. The robot itself has the property that if you modify the magnetic field, so you make a magnetic, like you spin a magnet near it, it will spin in response. And if you move that magnet around, you can steer this thing. And
Okay.
using that, the idea is you can inject it into somebody's arm, have it swim up to their brain, and if they're
Now,
having...
it's not really swimming, it's flowing.
it's actually, it's spinning, and when it spins, it swims, right? Yeah,
Okay.
it's
Oh,
like,
it's swimming,
like the way a
okay.
jet engine kind of goes, I
All
guess.
right, okay.
I mean, it's sort of sucking in it water at one side and kicking it out the side, so
Okay.
it makes it go.
How does it do that?
Well, it's a very careful design of the shape. They actually use kind of origami techniques to make it and 3D print it. And it's got a little bit of magnetic material so they can make it spin.
Okay.
So it gets to your brain. If you're having a stroke,
This is making me uncomfortable.
well, the stroke will make you more uncomfortable, right? If
I'd
it
rather
breaks
deal
up-
with the arm, but
If it breaks up the blood clot and your stroke goes away, you'll be much more comfortable.
no, I guess I would. Oh
So
my
that's
gosh.
what they're trying to do. If you imagine that you can carry a little bit of medicine in that and take it
Sure.
to your tumor
Yeah.
and apply chemotherapy directly to the tumor instead
Yeah.
of throughout your whole body, you can imagine why that might be a good thing to do in the future.
So are we close to making that happen?
They're at the stage where they've proven it can break up blood clots. They've proven that it can swim through against the flow of the bloodstream, and they're getting ready to try it in pig studies.
Oh, that's fascinating.
So this is joint work between Renee Zhao's lab in mechanical engineering at Stanford and the medical school and computer science. So they all kind of work together to get that work done.
That's great. Is there some other non-traditional applications here?
The other one that I think is really fun is we've got this robot that goes deep underwater and lets a person on the surface touch like artifacts from 2,000 years ago. And pick up a vase from a sunken Roman ship and bring it back without destroying it, even though it's way deeper than a diver can go.
Yeah.
That's really interesting.
So what did we have to develop to make that possible? What are the components of
Well, again, we have that haptic interface, and then we've got you try to make a robot such that when you have all that pressure, at 1,000 meters below
Yeah.
the surface at a kilometer, all the water of the ocean is basically pounding down on you.
Yeah.
And you know what happened to that ship trying to go to the Titanic, right?
yeah.
If you
Oh
get it
my
wrong,
gosh.
it's just gone.
Yeah.
And so they do some cool tricks. They put oil inside the robot that's it's balanced at the same pressure as the water pressure, so that you can't have salt water inside because it'll short out the electronics, but the
Right.
oil can be non-conductive.
Right.
And then you can have a robot that is lighter in water than it it's not like made out of super thick titanium to resist the pressure. You just give into the pressure. It works.
And how would you control that then?
You control it by it still has motors, and you
Yeah.
make the motors move it. You connect it to a device on the surface, so a person is
So this could be
looking.
wired up to something else.
It's wired, yeah.
Yeah,
And one of the challenges is actually managing that tether. If you think about a tether that's a kilometer long, like half a mile long, it's a long
Yeah.
tether. Could get tangled up and stuff.
What else is coming out of the Robots for Humanities? Any other interesting developments there?
So I think Robots for Humanities. Henry has continued to do a lot of different experiments. There's a project out of Northwestern here. They're looking at how do I make it so that somebody can control a powered wheelchair with something other than the joystick, right? The powered wheelchair will ship with the joystick.
Yeah.
But what if you don't have control of your hand? How are you going to control it? And so there are other controllers, but it ends up being like a tough integration project every time.
Yeah.
And so the people at Northwestern, Brendan Argall's lab, are working on how can we create a way to drive this thing, to let a person drive it, but I need to be able to build a system quickly because, everybody's disability is a little bit different. Disability is not really a great market, in the
Sure.
robot market sense. But if we can have the ability to easily construct a solution, we can help people, live independently.
Are there any? Is there any research going into kind of incorporating robotics within the human body?
Well,
Other than,
so there's actually it's another interesting case. So a lot of people, amputees, right,
Yeah.
don't have control, and so the question, if you go back in time, the most you could do was a hook, right?
Sure.
And people would have like a hook with, and people actually have done a lot of research into the shape of the hook so that you can open doors, and it's as useful as it can be.
Yeah.
But more recently, we can build hands with 5 fingers that, I just a couple months ago, shook hands with a guy who was wearing one, and it was completely prosthetic, but he could actually, he couldn't do everything. So he could do this kind of grasping, but he couldn't do the Spock thing. You don't need the Spock thing for a lot of things, but there's certain, everything that you move is a different motor.
Yeah.
And so you try to balance, like, let me keep the smallest number of motors, but the most functionality.
And how was he controlling that?
It was actually measuring, his nerve endings were wired to it so he could control it. So actually, the hand was not as expensive as the interfacing it to his body, right? But what's also interesting about that is there's all this work going on now in humanoid robots. And humanoid robots, some of them, like the PR2 that we talked about, had just a parallel jaw gripper. That's just basically two things opens and closes. You can put this kind of hand on a humanoid robot, and you could do more tasks. But when the one that's used as prosthetic, if it's the same as the humanoid, you've just increased the size of the market to all humanoids and everybody with this.
Yeah.
Which means that you can invest more in trying to solve that problem.
Yeah, that's amazing. And what would that hand you just described, what do you think that cost? Do you have any statistics on that?
I don't know off the top of my head, but it's not like hundreds of dollars or thousands. It's probably in the tens of thousands to get one that works. Maybe they'll come down into the thousands.
Well, of course, the cost for developing it is different from
and part of the problem is, if you mass produce it, you can get the cost down.
So you said that at one point you produced 50 of these.
The PR2 robot,
PR2
that was the early one.
What was that?
Personal Robot 2.
Yeah.
The first one was, PR1 was a one-off that was built at Stanford.
Yeah.
And the students came to Willow Garage to basically take it to the next level.
And what did those cost? Just to produce,
That robot,
just to make them, not the product, not the
cost
research.
of making it was just over $100,000 in 2010.
And you sold them?
And we sold them for, the list price was $400,000. We sold mostly to universities at a 30% discount.
Yeah.
But it wasn't like you could buy one for your home, right? It's not.
Well, some people are paying that much for their cars, right?
Some people could, but most
might.
people can't, right?
Yeah. Is there a novelty interest in this that you're aware of? Are there people investing in it just for the novelty?
I don't think investors invest for the novelty. I think they hope they're going to get their money back.
Well, and anybody who's buying something like this right now is pretty much an investor.
Oh, so
right? Yeah.
well, okay. So if you think about like early cars, right? There were people who were or early electric cars, right? People were buying the Tesla Roadster at six-figure prices.
Yeah.
And not very many of them, right? That was, but for robots that are going to actually impact most of us, the price matters a lot. We got to get it down to where people can afford it.
Yeah. Well, so who else is working on this? I know obviously Stanford's been in this game for a long time. Google has worked in this area. Who are your peers and competitors?
Well,
here?
of course, Google is interesting because they identified early on that self-driving cars was one of the areas of robotics, and so Waymo is a spin-out from Google that has been going on for 20 years. And one of the messages here is when you have a vision like self-driving cars, it can take a long time before they get from demonstration, you see a video of it, till it's actually a product. Of course, there's great universities in robotics as well. MIT, Carnegie Mellon are very strong. Carnegie Mellon was visionary. In 1980, they created a robotics institute, which has been going on for 50 years now. So, and a lot of schools. I don't want to name any more because I'll leave some out.
It's a long list. Okay.
Yeah, exactly.
Well, so let's stay with the cars for a second. Where is that at right now? I haven't been tracking this. I mean, are there cars out there on the road today that are robotic, that don't have drivers in them?
Yeah, so if you go to San Francisco, you can take a Waymo taxi. You order it the same way you order Uber. It shows up and there's nobody in it, and you can get in.
There's one of those in another Arnold Schwarzenegger movie, Total Recall.
Total Recall had the Johnny Cab.
Johnny Cab, yeah. Right?
Yeah, Johnny Cab was funny, but the Waymo doesn't have a driver in
He's
there.
not going to talk to you.
He's not going to talk to you. You just get in and it takes you.
What's the point then, right?
Well, it gets you where you want to go.
Oh, okay.
That's the whole point.
So that's actually going on.
Yeah, that's actually happening today, and there's there's, cars, more and more they call it ADAS, Advanced Driver Assistance Systems, like you have on your car. It's, it'll keep it in the lane, and it'll keep it from hitting the car in front of you. And you could take your hands off the wheel in some of them. Some of them will yell at you, but if you're on the highway, it's fine. And then there's,
I mean, how fine is that? Because my car does that, and I get nervous.
Well,
that my hands aren't on the wheel.
I mean, I think it's actually, I feel safer when I'm driving it, because like I use it all the time on the highway, because I feel like I'm always in danger of, I got distracted, I looked away, and the crash in the car in front of me. And so now the car's doing that and I'm doing that. So we have like double layer of protection against rear-ending the car in front.
Right. I guess that's how I look at it too. So, but I mean, the kinds of cars we're talking about, it's just keeping you in the lane basically. They're not turning corners or.
Well, they can. I mean, the Tesla, Elon's been promising this since 2018, but it's getting better. And I've done that. I've driven that car and let it take me. And I've even had a couple trips where I didn't have to intervene, but most of the time I do at this stage, and it'll probably come.
It made you nervous?
It doesn't make me nervous. The thing that's nice about it is if you grab the wheel, it gives up and you take over, right? It would make me nervous if it was fighting me, right? But it sort of gives up right away.
And when you were in school, did you imagine that we would get to this point?
I had hoped. So I played early in my undergrad days. I had a robot arm that I could program, and I wanted to write with it. I wanted to program to write. And the problem is that it was what's called a position-controlled robot. That's all the industrial robots were position-controlled, and it wasn't particularly precise. And so you couldn't actually keep it on the paper. It would be like doing this, and so you wouldn't actually get the mark.
This is why we're afraid of robots, but go ahead,
Well, I mean, position-controlled robots are a bit scary, because if you tell it, like, I want you to go down and touch the table, and you're off by 1 centimeter, it'll go through the table. Right. Especially industrial arms, they're really strong. But a force-controlled robot, you tell it, go down until you feel so much force, and then stop. And those kind of robots, you could have it wipe the surface, right? So we're getting to the place, where we understand how to program the whole body of the robot at once. Actually, you could also, if you're going to get into robotics, you could get into mathematics. The mathematics behind how you deal with robotics is very elegant. It all comes down to matrices.
I just, as we get to the end here, I notice you've been in a lot of interesting places throughout your career. One of them was you were at Xerox. In what area were you doing?
Xerox PARC. I was doing human-robot interaction and document systems back then. Digital library work.
Xerox did a lot of innovative work in a number of areas.
They did.
And with some other stops along the way for you.
So I started my career at Washington U, not too far from here, in the medical school, looking at medical informatics. And that work actually ended up being contemporaneous with the World Wide Web. So it was a long time ago. And then Xerox PARC was interesting. There was a lot of cool work there. And then I went to IBM Research, where it was a little bit more focused. The research was more focused on trying to get technology out in the world. One of the challenges is always, how do you get technology out of the lab and into the world? And that's kind of also been a recurring theme in my career.
What's the culture like if you compare the Stanford Center with Xerox or with IBM? Is that a factor, do you think?
Well, it's different because
you were doing open source, I think.
Open source can happen at any of those places. What's interesting about a university compared to a research lab is that in the university, you have students who come through, right, take the classes, do their research, and they move on. So there's this constant flow of students, and the faculty have one of their jobs is to teach students. If you go to a research lab, like a commercial research lab, you have people who got PhDs, could be faculty, but they've chosen not to, so they don't have to teach. They don't have to advise students. They can spend all their time on the research. So it's a little bit different culture.
I mean, do you think that one's more stimulating than the other? As a professor, I'm hoping you're going to say the academic
I think
environment.
Actually, I mean, I'm back in academia now, and I do think that the flow of students is very interesting, and there's just so many interesting ideas. The way things get done is really different than corporate, but it's it's fun to be back in academia.
Yeah, you were hired by one of your former students, I understand, right? Or you partnered with him or something? It was an intern of yours?
Oh, well, I hired one of my former interns as an intern, and then he hired me to run Willow Garage.
Right,
So
right.
he made it big. So
So he while he was away from you, he made a lot of money and he came back and started a project with you.
yeah, exactly. He started a company and asked me to join it, and I said, yeah, of course.
That's a very rewarding experience. That's all the time we have for our program. Thank you to Dr. Steve Cousins for joining me today on the Roundtable Perspective. I'm your host, Tom Roach. See you next time.